As can be seen from the videos linked at the end, over the years I've had a few opportunities to see the International Space Station transit the Moon already, both sunlit and in Earth's shadow. I also had a few predictions of ISS-Solar transits already, but these were always during the week when I'm at work or it was cloudy when over a weekend, meaning I never saw one yet. I was delighted when Sky sent me an email alert of an ISS-Solar transit due on Thursday 21st of March 2019, since it happened to be on a public holiday in South Africa. The long-term weather forecast looked good too. Since the event was happening in the late afternoon and my yard has lots of tall trees, I got my daughter the day before to pick a good spot where the sun would be visible at that time. Sky showed me that my house was in the best possible position to see ISS transit the sun right through its center. A similar prediction was shown by www.transitfinder.com, suggesting that my house was only 480 meters from the center line of the 14-kilometer wide visibility strip. Since the phenomena happens to be relatively close to the horizon, the transit takes surprisingly long, 1.03 seconds to be exact. This unfortunately meant that the space station would be relatively small, just over half an arc minute, being nearly 800 kilometers away from me. As always, I also did a simulation with Stellarium, mainly to give me the correct orientation. I find the others quite confusing. Interesting, Stellarium's time differed by a few seconds and it did not predict the transit as central as the other two, but gave me the relative angle and direction it would cross the sun's disk. My neighbour's son, Jacques Lambrechts, joined me for the observation, and with about an hour and a half to go, we started setting up on the spot that my daughter identified, which was just getting sunlit. This may sound like a long time, but it is surprising how quickly time passes while you try things out and orientate yourselves. Before pointing at the sun, it's very important to fit both the telescope and finder scope with safe solar filters. Since there are no stars visible in daytime to orientate the mount, I just let it auto-align so that it can track the sun. The old minimize the shadow trick again came in very handy to point the telescope at the sun. After checking the sun visually, the video camera was mounted on a special 3D printed bracket. The bright sun makes it quite difficult to see on the video screen. I battled a lot getting the focus right with the 28mm eyepiece I always used. I therefore switched to an old design 40mm eyepiece, one that I have not yet used for video, which was a mistake. The eyepiece's focal plane is very close to one of its lens surfaces, so that the video camera focused on the dusty lens surface instead of the sun. Luckily they were close enough so that the ISS transit was just visible. If you look closely, you can also see a few sunspots. As said before, compared to my previous sightings, which all only lasted fractions of a second, this one was relatively long, lasting just over 1 second. It did indeed cross quite central as predicted by Sky and Transit Finder. ISS was recorded on the sun in 52 frames on the video.